In this lesson, we're going to be looking at surface area. Our objective: understand basic concept of surface area, understand surface area formula for a cylinder, understand surface area formula of a regular pyramid, and understand surface area formula of a cone. Some important vocabulary. Bases. Bases in this situation are the top and bottom, typically, of our shapes. Lateral faces would be the sides, and then the slant height. A lot of times the actual vertical height isn't what's important in these. It's actually the height of the slant, or the distance of the slant of a cone or a pyramid that becomes more important. So here I have two shapes. What we want to look at is the basic idea of surface area. Surface area is really just drawing all the faces. The faces are all the sides. The base of this shape would typically be the top and the bottom faces. Here this one has one base right at the bottom. We like to draw out all the shapes individually, label them, and find the area of each face. And then all we do is add them all together. That's our most basic idea here. So for this one, we'd basically draw 6 rectangles and find the area of all 6, add them together. In this shape here, we would find the area of the rectangular base, and there would be 4 triangles that we would need to find the area of. Alright, so what I've done is we want a formula for a cylinder, because cylinders are a little bit more difficult because of the circles in them. So what I've done is I've drawn a cylinder out, and then I've broken it into its 3 parts. A cylinder has 2 circles, which have the area r squared pi. So part of our formula would be, since there's 2 of them, they're going to be exactly the same. 2r squared pi, and then we're going to add to it. I call it 2 because I'd rather multiply by 2 than add it twice. Our second one here, if you notice, the rectangle is just, if we cut this out and unfold it, it'd be a rectangle. We've got the height of the cylinder, and this would be the circumference, which usually the circumference is d pi, is what we learned, but 2 radii are the same as diameter. We're already working with radius, so I use 2r pi. So we just multiply these and we get 2r pi h. So I'm going to add that in here. And then so this is one version of the formula. Then using an algebra term of factoring, we can also write this as 2r pi times the sum of r and h. So we've got 2 methods of writing this. And some people also like to write this one up here as 2rh pi. Alright, that's surface area of a cylinder. Now let's look at a regular polygon, or a regular pyramid. So a regular pyramid, I didn't draw it all out because it's actually not that difficult to kind of figure out as we go. A regular polygon, we just use our regular polygon formula. Number of sides times the apothem times the side length over 2. That was one of them that we came up with. Then we've got the triangle. Now with this triangle, the height isn't important. Again, it's our slant height, which we're going to call L for slant, L for slant as in SL. Okay, so what we need is we need to find the area of the triangle, and we multiply that by the number of triangles. So N, remember, stands for the number of sides. That's how many triangles there would be. And then the triangle formula is 1/2. Our base would be our side length, and our height of the triangle would be our slant length. So if we reorganize this, it would be NSL over 2. And we would just add all of this together. So we have NAS over 2 plus NSL over 2. Since they're both over 2, we can actually put them together. So there's another way to write it. And our last version of this will be using a little bit of factoring again. So if you notice, N and S are in both of these. Okay, and then if you wanted a fourth version, remember N times S is otherwise known as perimeter. Alright, our last one is a cone, and I've drawn a little bit more with this. There's our r squared pi for our circle, and then if we cut this and unfold it, it would look something like this. What I've done is I've cut it into equal sections. We'll say that they're equal, kind of like when we found the area for a circle, how we folded it into those pieces of a pizza, and then what we did was we cut them out and we reshaped it as a parallelogram. Well, I've done that again. Here's our slant height, and this would be r pi, or pi r here. So the area of the unfolded part is going to be, so we've got r squared pi plus, this is going to be r L pi when we multiply these together. So again, we can rewrite this by factoring a little. And our rewritten way, running out of room, so I'll do it to the side here. We can pull an r and a pi out. Alright, if there was any part of this video that you kind of missed or you didn't completely understand, make sure you pause, rewind, and rewatch, and bring any questions to class. Thank you.